Today's topic is applications on curved surface and a plane surface formula. Here the very first problem is about a bird problem, right? Bird problem. Look at that question, what is asked actually. A bird is flying down vertically towards the surface of water in a pond with a constant speed. There is a fish inside the water. In that, if that fish is exactly vertically below the bird, will appear to the fish to be, right? So here, what is actually given? A bird is flying vertically down. So here it is moving vertically down. What it has below it exactly? A pond. So water surface is there. Inside the water, there is a fish, right? Then look at the last sentence. If that fish is exactly vertically below, the bird will appear to the fish. So here, which is object, right? Which is object and who is observer? That I want. Anybody? Which is object and who is observer? According to the question. Anybody? If that fish is exactly vertically below, the bird will appear to the fish to be, right? Just focus on this. Bird will appear to the fish will be. So which is object?
Fish is the object.
No.
Sir, fish is observer.
Right.
Eagle is object.
Bird will appear to the fish. So fish is observing the bird. Fish is observing the bird. So it is observer, right? This is object. Clear? So there are many possibilities where the bird will be appear to the fish, right? Where the bird will be appear to the fish. So here that may be at exact position or farther away than its actual distance, right? Here, if it is observed exactly at this distance, so object and image will be at same place. If it is observed away from that farther position, so image distance will be increased because here bird is in the air and the fish will be in the water. So here fish observe image of the bird, not the bird exactly. As you observed the lemon in the glass of water, what you viewed? Image of the lemon. So eyes like that, the fish will observe the image of the bird here. So if it is farther than its actual distance, the bird will be appear to the fish is here, right? So that is observed, suppose closer than its actual speed, actual distance, then it will be observed at this spot. So these are the possibilities here. So the bird figures are here, images, right? Here the object also may be image. We don't know exactly which is observed by the fish here. If it is exactly at the same place, middle bird will be observed by the fish. If it is observed farther than its actual distance, the upper bird will be appear to the fish. If it is closer than its actual distance, then the bird will be appear to the fish at below this bottom bird. So these are the possibilities, right? So here, if it is farther than its actual distance, here in the question, it is clearly mentioned, it is moving with the constant speed. If it is at a far distance, right? So here, who is on the land? Who is on the land? They can see the bird is moving with a constant speed. But fish, your object is at exactly viewed. If you are on the shore, this is object for us. Who is on the land? That person can see the object at this place, right? If the fish is observed far distance, this will be visible to the fish. The bird will be appear at this spot to the fish if it is far, right? Here it is moving with the constant speed vertically down. Then if the bird is appear to the fish to be here, then what will be the speed of the bird? Will greater than the actual speed or less than the actual speed? Can anybody answer? If it is far, it is covering something distance greater than object. Image distance is greater than object distance. So here simply what happens, if it is maintaining the constant speed same as like the object, the bird will reach here, original bird, then the image will be remains at a certain distance. Is it possible? Is it possible practically? If the bird reaches the surface, where will be its image? Image also reaches the surface. So in this case, that both speeds are same? Never. Here the image will move greater than its actual speed, more than its actual speed. If A is true, there is another possibility. It will be move faster than its actual speed. If B is true, closer than its actual distance, what will be the speed of the image? It decreases. So here another possibility is moving slower than its actual speed. So depending on the options, you have to go for another possibility. Suppose A is true, I'll go for C. If B is true, I'll go for D. You are able to prove it. You are able to prove it, right? So how to prove? Which of the following are true? Which of the four options are true? How can you prove it? Shall we prove? Are you ready? Is it clear what I am given explanation for the question? Right. So now we'll go for the solution of this question. Right. So here I don't know the distances above the water, right, and below the water. So I don't want below the water, because where the bird will be appear to the fish, above the water or below the water? Tell me. Where the bird will be appeared to the fish, is it above the water or under the water? Suppose imagine yourself here, you are observing outside, you are lying yourself under the water, you are observing the outside person. How do you see? Right? So this object and image both are above the water. Both are above the water. I don't know which is exactly image for the fish. Maybe the original, or at far distance, or at near, closer distance. Right? So among the three, whatever it may be, it act like image for the fish. Right? So this is object, right? Then I'm taking the distances here. I don't know the distances. So object distance I am considering here as unknown value x. So x is what? Object distance. X is what? Object distance. So among the three, we don't know which is going to be act like image. If original is only acting like the image, then the distance will be same. Image distance will be same as the object. If it is far, I'm taking that distance as something unknown value y. Right? Unknown value y. Here, y is image distance. So here, I can take the remaining distance also. What? Here, to this spot, already I know image distance is x, but for all the three cases, I am considering the distance as same, x only, sorry, y only. For all the three positions of the bird, I consider as image that all the three I am taking y. So how you can take, we are able to see clearly there are different locations. How do you take that equal distances? Can anybody asking like that? I'll tell you. If you have doubt like that, there are three positions. How you are considering that distance 3 is y? No doubt like this. Why I'm considering that image distance all the three positions y? No one? No doubt? Yes, Abhinay,
Sir.
have you got this doubt?
Yes, sir.
So here simple, look at this. Here I don't know the distance where the image will be. I am considering blindly. Why? For the first position or for the second position or for the third position, right? I don't know this. What exactly? That y may be equal to x, y may be greater than x, y may be smaller than x. So by satisfying any condition, I'll conclude that our image may be exactly at original or far or less, right? So I have to prove among these three anyone by finding y value. Compare it with x. So with this, you will get clarity, right? So I'll give you that explanation. So for all the three positions, I'm considering the distance size y. Finally, how I can find out that? By finding y is equal to x, or y is less than x, or y is greater than x. Three possibilities are there. So any one only true. Among the three, only one is true. So which is that? We have to find out. So I'm going for that. So before going that, I'm showing you images. Maybe original act as image, or I act as image, or I dash act as image. Anything is possible, right? So here simply let us take all the three distances as y for the image, right? So here, how to find out the image distance here? What surface I am dealing here? What surface I am dealing here? Is it a
Plane
curved
surface.
surface or plane surface? Curved surface or
Plane surface.
plane surface. So what is the plane surface formula here? What is plane surface formula here? N2 by V minus
Sir,
N1
N2 by V minus N1 by U.
is equal to what?
Sir, equal to 0.
0. So N2 by V minus N1 by U is equal to 0, because plane surface has the radii infinity. 1 by infinity equal to 0, right? So here we need to know what is N1, what is N2, what is V, what is U. Can anybody, what is N1? Which is considered to be as first medium here? Air or the water? Air is considered as first medium, or water is considered as first medium? Here, first medium will be decided based on the position of an object. Where is your object? Where is your object? In the air or in the medium water? Object is in the air. So here simply we will consider refractive index. Refractive index of air is N1, right? So first medium refractive index is N1, right? So here, according to our assumption, so what the object is the middle bird, right? So here simply object is there at, right, at x distance. So object distance u is equal to x. Apply the rules of sign convention. What is your incident light ray direction? Where the light ray incident? Here from the object to the water surface, right? So this is what incident light ray. So here your measurement always from the pole. So here from this point you started measuring distance in this direction towards the object. So how they are opposite to each other, or both are in the same direction? Opposite to each other. So what the symbol we can use here? Negative. So here simply your object distance will be taken as minus. U is equals to minus. Then where will be the image? Our assumption is image distance y. So where you can measure, it is also above the water. It is also above the water. So here image distance v will be taken as y, right? Because here object is above the water and image also above the water. Then image distance v is taken as minus y. Y is the distance, minus is indicating you are measuring opposite to the incident light ray, right? Same side as the object. So this is the mean. So I got u and I got v. What I need? N1, N2. What is N1? Refractive index of air, medium 1. Refractive index of medium 1. Then refractive index of medium 2 is water refractive index, that is N2. So I am taken here. N1 is the refractive index of air, N2 is the refractive index of water. Okay, so it is air. So we have two different mediums. So actually, which light is received by the fish? Refracted light or directly from the bird? It is receiving refracted light because the light propagating from rarer medium to the denser medium, automatically it will refract. So refractive index N1, we will take it as 1. It is refractive index of the air. Approximately we are taken 1. Actually refractive index of air is 1.0003. Approximation is given as 1. Then water refractive index is N2, unknown value, that I am taking as something N, right? So N2 is the refractive index of water, that is taken as unknown value N. So let us substitute that values in the equation. Are you clear about these measurements taken by me? Everyone, look at the picture if you have any doubts. Clearly I am giving in the picture, right? So I got u equal to minus x, v equal to minus y, n1 equal to 1, n2 equal to n. Let us drop that values in the plane surface formula. N2 is equal to n given, substitute. That is in the formula n2 by v minus n1 by u is equals to, I have that n2 value as n, so substituted. Then v value is minus y, substituted, minus already in the formula, minus n1 is 1 and u is minus x. That is equal to what? 0. Because I substituted LHS equal to, right? LHS substituted here. Okay, that RHS is equal to what? 0. Then here n by minus y, minus conveying to the numerator, then minus into minus in the second term will become plus. So n minus n by y or n by minus y as it is written, no problem, is transposing now here. This term I am transposing with the same symbol. So minus will become plus, minus will become plus on right side. So in the denominator, we have minus x. Don't forget that. So here as t is I am transposing, minus will become plus. So 1 by minus x written. So here on both sides, minus minus will be cancelled. On both sides, minus minus will be cancelled. Then cross product, take the cross product, n into x and y into 1. So finally, what we are able to write, y is equals to, by taking the cross product, we are able to write y is equals to n into x. Is there any confusion? Mathematical procedure. Is there any confusion? Go for quick reaction if nothing is there. Just I taken mathematical steps, right? Transposing and symbols cancellation on either sides, right? So here I got y is equals to an x relation. So what is y here? Speak out. What is y? Anybody speak out? Unmute.
Sir, image distance.
Very good. Y is image distance. What is n?
Refractive index of water.
Refractive index of water. What is x?
Object distance.
Do you know that values? Do you know that values? Don't know. So I am going for assumption. As you find the values in the graph, mathematics graph, if you have any equation, assuming the value of x and finding the value of y and plotting in the graph, right? So like that, I am going for assumption here, right? So I am taking the value of x as something 100% 1, right? X is taken 100%, and I know the refractive index of water according to our 9th class lesson 1.33. So here I am taking n equal to 1.33 refractive index of water, and object distance is taken x equal to 1. It is assumption only to get idea about y, image distance. So you are able to find out by substituting that values in the relation y equal to nx, right? So here the image distance y will be given as here 1.33 into 1. Any confusion? Just it is assumption. Any confusion? Just assumed, right? So I got y value here as 1.33. Is it greater than x or equal to x or less than x? It is greater than x. So I got my answer, right? Y is greater than x. So image will be appear to the fish at what distance? Far distance. So which among the assumptions are correct? Here the bird is observed at far distance. So upper, this is the image. So y is greater than x. The bottom what we assumed, that is wrong assumption. So I remove that. So here image distance is greater than object distance. So here now I got first one as correct option. Then what will be among the C and D? Which is correct? Which is correct? Because why I asked, suppose here I am on the shore, I am observing the same fish at a time, the bird will observing the same, sorry, I am observing the bird here. This fish also observing the bird, same, right? So here I observed from the shore, the bird is reached after a certain time. What about? Actually, this fish cannot see the bird. It can see the bird at this distance, right? Here v velocity equal to distance by time. So original object is covering the distance in a certain time, right? Then image also traveling certain distance y within the same time or different time, that I want. Image and object reaches the water surface at same time or at different time intervals. Please tell me. Not clear? I'm not clear? Speak out. Rohit, any confusion in my question?
No, sir.
Then why you are not answering? Medashri,
Yes, sir.
you tell me. Do they reaches the water surface at same time or in different time intervals? If they are reaching that surface in different time intervals, here I can see the bird here after certain time t. The fish can see here bird at this spot. Is it possible? Is it possible? So simple to understand this one. Imagine a mirror in front of you, or take the mirror directly into your hand now only, right? So here in front of the mirror, I am moving certain object. Where will be the image? Inside the mirror at certain distance. Yes or no? Answer me. I'll help you to understand this one. Imagine a mirror or take a mirror directly in front of you, move certain object, or maybe your hand move towards the mirror. So when you move this object towards the mirror surface, what about the image inside the mirror on the surface? Will it remain at certain distance, or exactly it also reaches the mirror surface? No answer.
Image also reaches.
Image also reaches the surface at a time. So here the same thing. Image and object will reach the surface at same time, but they are covering the different distances. What, sir? Already I assumed what? Y is equals to 1.33. So V1 equal to 1.33 by T. V naught, V object is equal to what? 1 by T. Right? So here to reach in the same time, suppose the time I am taking 1 second, right? So V naught equal to what? 1. V1 equal to what? 1.33. Is it clear? So whose velocity is greater? Whose velocity is greater? Image, right? So image moving faster than the object. That bird actually realizing this one, right? Because it is observing the image at far than actual position. So when the bird reaches the surface object, image also reaches the surface. So it is impossible if it is traveling with the same constant speed. So the bird will be appear to the fish as moving faster than its actual speed. So this is the information we brought from the assumption. So option A and C. Option A and C both are correct for this explanation. Right? Both are correct. Option A and C. If you have any confusion, just first observe that image and object, do they reaches the surface at same time or different time? Then only you can understand. Okay, then only you can understand this clearly. Is it clear, everyone? Is it clear? So if there is any confusion left, once again follow the steps. Do yourself. Do yourself. Don't follow my record. Right? Just do yourself. Okay. So this is example 1. So our meeting time completed. Join immediately in the next one for example 2.